I'm Charles Pooh.
I'm Alec Shedelbower.
And we'll be talking about the Unity and the integration with the Wolfram language. Okay. I think most of you have been, we are here last year, and, we made a pretty nice demo about Unity. So we are going to give you kind of the state of, the package, UnityLink. Kind of give you the vision of how we see it in long term and the integration in the Wolfram product and what we plan to do with that. So that will be the first part of the talk. And I'll probably give a short view of the integration from the Unity side. And then Alec will take from there and talk about the Unity from the mathematical Wolfram language side and all the nice demo and such he built and other people built with Unity. Okay. So first, most of you here know the Wolfram technology and the Wolfram technology stack essentially. So I'm not going to go in detail, about all what we have, but we kind of just try to give you the idea of what we'll bring to the Unity side, essentially. So one first thing is to know that, we advertise the Wolfram language, but, we are not going to say to Unity developer, which essentially use C# to write their code in the Wolfram language. So that's not the main objective, even though you will do that there, and we'll show actually how you can write some code, some Wolfram language code, and reload it if the kernel is running behind the scene. What we think about more is the Wolfram language or the Wolfram product to be a support and extension of the Unity engine. Right? So depending on what you are doing, if you're a professional game developer or you are somebody working in education to teach people how to learn to do game development, how you can use the Wolfram language and Unity together to kind of ease your work. So let's suppose you are, you're a teacher, right? Decide to teach your, high school kid game development, just the basic, how to build a simple pendulous. If you want to do that with Unity, you have to write a C# code. So you have to teach them C#, that will take time around all that and such. But you can easily just take the Wolfram language, have the UnityLink, and easily in one day, learn the basic about the Wolfram language and be able to make your simulation with Unity. So that's kind of the idea, if you are doing education. If you are professional, you can use, the set of technology we have through your development pipeline, from, starting in the design to, final testing and, QA, quality assurance of your product. Because with the UnityLink, you roughly have a full control of the Unity game engine. So during that process, having that full control of the Unity game engine means you can do quality assurance. Somebody can, essentially you can build a simulator from the Wolfram language to actually play your game. You can monitor how people play your game. So that's kind of the idea where we are going to. So essentially the Wolfram language is more a product and object on top of Unity. It's not really a language where we hope that people are going to sit and develop inside Unity with that. Okay. I hope that gives you a general idea. So on the other side, when you are a Wolfram language user, I guess most of the people here, what do you gain to actually use the UnityLink, right? One interesting thing is that Unity provides you an environment, a simulation environment. Right? So essentially, let's suppose you decide to simulate a pendulous or something physics. You can sit and build your model, is a PDE, such a thing, and solve it with ND-solve and have graphic and do the animation. Or you can just call Unity. You have a physics engine behind the scene. Well, it's not realistic simulation, but it's close to what you need to do. And some of the examples Alec will show will actually demonstrate that. So you can actually directly tap on Unity, use the physics engine, and have a feedback in Mathematica. That's one aspect. And in the Wolfram language, or currently in Wolfram product, we don't yet have animation. You need to have a whole engine and component there, so you can use it for animation. You have a jump for virtual reality, right? Virtual reality and augmented reality. So it's already there. It's all platform. So you can use it if you're a Wolfram user. You want to do something related to VR, to just Unity to give you the link, and there's a lot of more other functionalities. So that's roughly the idea about how we envision and see the integration between Unity and the Wolfram language. So, and that's slightly far from the coding and development, but just to give you an idea. So now I will just give you a short demo from the Unity point of view, and then after that we'll do from the Wolfram side. Okay, so we're always thinking about how you start. So if you're a Unity developer, usually you just want to start your Unity and load it. So here I will take let's text exist. I will turn off the analytic, and I will just create a project in Unity. So that's basic project. So it's loading some packages and all the different components. So this is roughly the Unity environment. So I will open here a package which we call the Wolfram package, or is a Unity package, which essentially contains all the components to do the integration. So what we did is that we automated everything there. As soon as you just take that package and drop it inside Unity assets. If I manage to click on it. What happened? Interesting. Wow, that one. Actually, you are right. Maybe the. Well, let's see if I can do a copy and paste. Quite interesting. So, to the right of the name, maybe, or it's pardon?
Try going towards the right, like past the name.
Like past the name. Still. Well, interesting. Yep. Try a little bit. Nope. That's. Pardon? Do you use better touch? No. Oh, you managed to do that. Perfect.
There we go.
That was the magic.
Yeah.
So essentially, you click on it, and then it automatically loads, all the components you need. So from script to extended, extension to the editor. And what it does behind the scene is actually check your machine if Mathematica is there and connect to it. And actually, you can actually turn it off. It's just a preference. So roughly speaking, you see down there, he told you, okay, he loaded and he checked all the notebook. So essentially, this is connected to a kernel. You start a kernel behind the scene. So it's assumed that in your project, you want to use Wolfram tools. Right? And one way to see it is, on top there, you have now a menu called Wolfram. So the first part of the menu are the construct, game object, constructor. For example, you can say cuboid. What it does is behind the scene is called, the Wolfram engine here in the kernel, and then tell him, okay, give me the cuboid. The cuboid we have in the language. So you have it there. And let me switch in the scene. So there is the cube. Right. You can pick another object, the spiky. That one at least we recognize that that's our object, so it's there. Right. So it's, a game object is a mesh like, any component in Unity. Also the second, you also have the 2D object, which are actually directly embedded in 3D. And in the 3D too, we have all the, mesh generator and a general extension for all the primitives. In the 2D, you also have all the standard 2D, what we call our standard graphic primitive, listed there. We embed them in 3D automatically. So the last two sections, for example, are some more integration we do. So for example, if you say you want the language, this essentially create a game object. Instance, you can actually call in your C# script directly to actually call Unity. And what we try to do is to provide you essentially the different connections. So for example, you have a whole authentication and connection to the cloud. So you can actually do your evaluation directly through the cloud if you have the right authentication and credit, or to a remote computer or to a local one. The local one is by default. Or you can also use the different resource we have, here we have a data drop. So you can, for example, have a data drop there, you put the ID, and for example, use that data drop to actually track, event in your scene. For example, when, a session starts, you switch between session and such. So this is just kind of give you a little view of the integration we are trying to bring to the Unity side. So you can even stay in Unity and actually use that. And the rest is essentially in the different kind of interface. If you think about the evaluator in the front-end side, so you can start a front-end, for example, here. You'll automatically generate a front-end from that kernel, if it actually does that. Well, the notebook is somewhere. So we open the front-end, which is connected to that kernel, and you can analyze and such. So anyway, this is kind of the general idea of what we plan to do in the, on the Unity side. We can actually add more assets, more tools for you. I will let Alec continue and show the Wolfram language size.
Hi, I'm Alec. So I'm going to show more about the mathematical side of doing the UnityLink. All right, so I'll close this. Okay, so first I'll give a quick overview of Unity and UnityLink. Now I should go into some real examples of how you can use it in a certain game or project. So first, some core concepts. We have the scene. The scene is a 3D environment where all your game objects exist. Game objects are all the objects in Unity that actually, so they act as containers for components, where components actually do all the real functionality. So you have a scene full of game objects that have components. And then each component, they actually control things like lighting, physics, audio, and rendering, and pretty much anything you can think of. You can use some of Unity's default components, or you can even write your own using C#. There are also assets. Assets are any files that you can use within your game, and they don't exist within the scene, but in the asset folder. All right, so here's a little summary of that. So you have the scene. Scenes contain game objects. Each game object can contain multiple components, and components can reference assets within the asset folder. All right, so here's a quick overview of the actual interface on Unity. So we see on the left here, we have the game objects in the scene. In the center, we actually have the scene view. On the right, we'll see the components of the selected game object. And then at the bottom, we have our assets folder. All right, so let's actually get started. So first, you'd call needs UnityLink. It's already been called now, so it won't do anything, but it's already been loaded. Then we want to open a new UnityLink project. So just do Unity open. And then it'll automatically open Unity. So here we're going to want to go and create a new project. So hit new. If it opens, okay. Just set the name, location. Let's turn the Linux off. All right, then create project. Now automatically create the project, and it'll load the UnityLink package in it, or the Wolfram assets package. So you can see it made the project. Now it's importing the Wolfram assets, and it should appear down here. And there they are. So now I can go ahead and test to see if it's working. We can try to find all the game objects in the scene. You see it returns the directional light and the main camera, which as you can see over here on the left are our two objects in the scene. All right. So now the different functions for UnityLink can be broken up into 3 different sections. You have the create functions, which are for creating different Unity objects. Then there's also the find and delete. So we'll start with create here. So here you can create a new scene and give it a name. So we see it created a scene, and it's already saved down here. And we can see the scene name up here in the upper left. We can go ahead and create a game object from some geometry. So here we call polyhedron data with the alpha spiky, and then create a game object from that. You can see that added to the scene here. I make this a little bigger. Then we can also add create components. So here I'm going to create a light. Since I don't give it a game object, it will just create a new game object and add the light component to that. So here's that game object. You can see on the right here, it has the light component. All right, and then we can also create a Unity mesh. These are for assets. So this is a potential asset, so it can be referenced by different components. And now what's new this year is we can actually create it and add it to the asset folder. So I can do that down here. So now it returns a Unity asset, and we'll see it down here in the assets folder. We actually go ahead and replace the spiky mesh on our current game object with that dodecahedron mesh. Now you can see that there. So now that is using the asset in the assets folder. All right, so that's creation. We can do similar things for find. We can find the current scene. We can find a game object. Here we find that light game object. We can also find components. So on that light game object, we can find all the components on it. Here we see it has a transform and a light component. So we can go over here and check. So this light has this transform up here and the light component underneath that. So that's correct. And then we also have, what's also new is we can find all Unity assets in the asset folder. So I can call that here. So here we see that dodecahedron mesh and then the scene, which are what we have down here. And by default, I'll automatically ignore the Wolfram assets. All right, and finally we have delete. This is pretty straightforward. So we can delete a game object like that mesh there. We can delete a component such as the light on the directional light. Now we see that's missing over here. We can delete an asset. So here I'm deleting that mesh asset. So now that's gone. And lastly, we can delete the scene. So I'll delete the current scene. So now the scene is gone down here and it's unsaved up here. All right. So now I'll show a quick example of what you can do with UnityLink. So here we're going to do country selector. So it'll be a globe in 3D that you can spin around and then select a country. Once you select the country, it'll highlight it, and then it'll also display information about it. I can go ahead and open that up. So open up the project that has the demo in it. Just give it a second, okay. Go to the country selecting scene. All right, now I'll run it here. All right, then I'll go and run our code. All right, so now I should be able to rotate the globe and then click on a country. And now it's loading it. And now see it's highlighted and it shows some information such as the name, population, GDP, and so on. Now we're for any country. Try Canada next. And there we go. So now let's see how to actually do this. All right, so the main workflow here, first Unity registers a mouse click, then it gets the intersection with that click and the globe as the latitude and longitude coordinates. Then it calls UnityLink. Then once UnityLink is called, we have a function that will find the country entity, create a country mesh from it, and then set the country information. So first the actual call to Unity, or to the Wolfram language from Unity. We can see it here, it's only 2 lines. First we just make a query here, it's just a string, where we say the mathematical code we want to run. So here it's just set country, brackets, and the latitude and longitude. And then we call this Wolfram kernel.instance.evaluate on that query, and it'll automatically call the function on the Wolfram language side. So first, finding the country. So once we get the latitude and longitude here, we can get the geo position. We can see what that looks like here. So we see it's in New York. And then we can go ahead and find a country that's closest to that, which is here, the United States. Then we can go ahead and create the country mesh. So once we have our country, which is still the United States, we can get the polygons from it using country data. Then we can convert those to regions by discretizing them. So these are in latitude and longitude coordinates. So we can go ahead and convert those to 3D Cartesian coordinates using a basic function. So now they're 3D. You can see we can rotate them around here. Then we can combine them using region union. So now we have our full United States mesh. And then we go ahead and create a game object by passing it the country name and that combined mesh. So we can create that. And if we go over here, we'll see it added the mesh there. Yeah. And that's how the highlighting a country works. We can also go ahead and delete that. Now we'll go over setting the information. So to set the information, it's pretty easy. So once we have our country, we can say what property we want. Here we want the full name. We can get the text object or label that will contain that information. So here it's this one over right here. And you'll see it up here as the name. So we can get that. We can get the value of our country name. So there you see it's United States of America. And then we can go ahead and set the value of the text on that label to the name. So now we see it there. All right, so that's the globe demo in a nutshell. Here's all the code that's actually used. So here we see this is what's called from the Unity side. That finds the nearest country, which passes it to here, which creates a country mesh, and then sets country info, and then does some bookkeeping. All right, our second example is a 2D one, where you draw a digit, and then click a button, and it'll classify a digit from 0 to 9. So we can see the workflow here. First, you click a button. Then on Unity, it will crop and resize the image. Then it'll call the classified digit function on the Wolfram language side. Once Wolfram language is called, it will get the image data, it'll classify the image, and set the digit label text and color. So actually go ahead and demo that real quick. Go to the digit classifier scene. Run it. Runs, OK. Go ahead and run the code that goes with it. Right now, I should be able to draw a digit. Hit classify. I'll show a digit up here. Each time you click it, it'll be a random color. All right, so the workflow for this, I went over that. So now the first part, calling the Wolfram language from Unity. So we see it's also still 2 lines. This one's even simpler. It doesn't have any parameters. So you just have the classified digit function. So you call it. So once we get that, we're going to go ahead and find the Wolfram digit drawer component, which we can actually see in our scene right here. So we want to get this component. We can see the properties on it. We're interested in this pixel properties. So let's go ahead and grab that. So we can see it's just going to be a 2D array of 1s and 0s. I can actually show the entire thing here. A bunch of 1s and 0s. Then we can convert that to an image. And we see, for example, here is a 2. Then we can go ahead, once you have the image, we already have a trained classifier, so we can import that, and then run a classification on it to get our digit. Once we have our digit, we can find the digit text component. We can set the property of that text component to be the new digit, and we can also set the color to be a random color. So here it shows that 2, yep, and there we go. And here's all the code, so it's pretty short, only about 15 lines to get all that functionality. All right, that's it for demos. We also have made this VR demo over the summer that shows different functionality and capabilities with the Wolfram Technology Stack and UnityLink. And that's actually available in the basement, so you can go and try it out. All right, and then.
OK, thank you. Well, so essentially, most of those demos actually we did last summer, and Alec essentially worked on that. And we actually show it at SIGGRAPH, and we actually get some pretty good feedback from most of the game developers and such, especially the easy use of the Wolfram language for all the components. So from now on, what we plan essentially, we have a beta program running. If you want to join, that would be great. And we hope very soon we'll be able to release it, inside the Wolfram product, essentially. And I would like to invite you for the remaining, the conference to the UnityLink hands-on, which is tomorrow, Thursday. So if you actually want to play with it and actually build things, stop by or if you have questions. So it'll be 1 hour next Thursday at the Badger talk. And we also have the Geometry VR exhibit downstairs. So, and stop by and talk. And there are several people already using the beta version to build product. There's a couple of them actually here in the exhibit, and several others which are actually already using Unity in production. So, if you plan to do such a thing, feel free to stop by and we'll talk about it. So, thank you. Any question? Yes.
Yeah, I wonder, so if you inject the game object, it's a real object that you can attach a physics component to, and it has weight and gravity moves it, and you can deploy that to a phone app, right?
Right.
And then it doesn't need a kernel attached. But if you're doing something like this classified digit, is there a way that needs to actually be sitting on a desktop that has a kernel sitting there?
Oh, right. I mean, in the sense that you have to call the, you have to train, a network, you have to actually call it to execute, right? So it's where you actually execute that or do that call. So one best thing is that if you use our, our neural network, you can just call our desktop if you are using at home, or you can still actually call the cloud, right, to our cloud interface. Exactly, yep. So that also we are kind of showing that cloud interface aspect where you can actually just call that directly there. So you don't really need to have a kernel running on your device. So, any other question? Otherwise, thank you.